Hello. Thanks for joining us today. I am looking forward to chatting with you about your experience with Angular. To get us started, why don't you just give me a brief overview of your background and the kind of projects you have been working on over the last couple of years?
Hi, thanks for having me. So for the past 2 years, I have been working primarily as a front-end developer focusing on the Angular ecosystem. Most of my work has been on enterprise-level internal tools, specifically a few large-scale dashboards and a data management system for a logistics client. I have spent a lot of time building out reusable component libraries and working with complex forms and state management. I really enjoy the structured nature of Angular, and I have spent a lot of my time lately focusing on writing cleaner, more maintainable code and getting a better handle on the more advanced parts. RxJS.
That sounds like a great foundation. Since you mentioned the structured nature of Angular, let's jump right into the core. One of the biggest parts of that structure is dependency injection. For someone who might be new to the concept, how would you describe dependency injection in the context of an Angular service?
Right, so at its simplest, dependency injection is a design pattern where a class requests the objects it needs from an external source rather than creating them itself. In Angular, a service is basically a class that holds business logic or data fetching logic. Now, if I were to use the new keyword to create a service instance inside a component, it would create a tight coupling. That makes the code really hard to test because you cannot easily swap that service out for a mock during a unit test. Instead, you just tell Angular which service you need in the component constructor. Angular then looks at its injector system, finds the existing instance of that service, and provides it to the component. This promotes loose coupling and allows a single instance of a service to be shared across many different components, which ensures data consistency throughout the application.
That is a clear explanation. Now, you mentioned that sharing a single instance is often a benefit. Most developers do this by using the providedIn root syntax. But what are the potential pitfalls of making services globally available like that? And how do you usually mitigate those issues?
Using providedIn root is the most common way to create a singleton, but it does come with some risks. The primary pitfall is memory management. Because the service is a singleton that lives for the entire duration of the application, it is never destroyed. If that service holds onto large datasets or has active subscriptions that are not cleaned up, it can lead to memory leaks. Another big issue is state pollution. Imagine a user is on one page and some data is stored in a root service, then they move to a different part of the app or even log out, and another user logs in. If that data persists, it can cause very unexpected bugs where the new context is contaminated by the old state. It also makes unit testing a bit trickier because the state can persist across different test cases.
And how do you handle those pitfalls in your actual day-to-day coding?
To mitigate those, I try to be very intentional about what goes into a root service. I avoid storing large amounts of temporary data there. If the data is only relevant to a specific feature or a specific set of components, I use component-level providers instead. That way, the service is destroyed when the component is removed from the DOM. For global state, I always implement a clear reset method that can be called when a user logs out or switches contexts to wipe the state clean. And regarding the memory leaks, I make sure to always unsubscribe from observables in the service or use the take-until pattern to prevent background processes from running indefinitely.
Let's pivot to RxJS, which is a huge part of the Angular experience. You'll often find yourself choosing between different types of subjects. Can you explain when you would use a subject versus a behavior subject?
Sure. I like to think of a regular subject as a live radio broadcast. You only care about the events that happen from the moment you start listening. If you join the stream late, you miss everything that happened before you tuned in. It is great for event-driven actions where the past does not matter. A behavior subject is different because it requires an initial value, and it always remembers the very last piece of data emitted. So when a new subscriber joins, they immediately receive that most recent value. This makes it ideal for representing a state, like the current user's profile or a theme setting, where any part of the app that starts listening needs to know the current status immediately.
That's a good analogy. Since we are on the topic of RxJS, let's go a bit deeper. You mentioned ReplaySubject in your studies or work. How does that differ from the other two?
A ReplaySubject is kind of like a hybrid, or like a DVR for your data stream. While a BehaviorSubject only remembers the single last value, a ReplaySubject can be configured to remember a specific number of past values. For example, you could tell it to replay the last 5 or 10 emissions to any new subscriber, regardless of when they joined. So, if you have a stream of recent notifications, a ReplaySubject allows a component that just loaded to see the last few notifications that happened while it wasn't active.
I like that. Now, imagine a more complex scenario. You have a component that has multiple data sources updating asynchronously. It's getting a bit chaotic. How would you architect the service layer to consolidate, debounce, and process these inputs efficiently?
In that case, I would implement a state management service to act as a central hub. I would avoid letting the component handle the raw API calls directly, because that leads to messy component logic. Inside the service, I would use a combination of RxJS operators, like merge or combineLatest, to unify those various data streams into a single state object. To prevent the UI from flickering or overloading by performing too many updates, I would apply a debounceTime or auditTime operator to that combined stream. This ensures the UI only updates after a short period of stability in the data. Then I would expose this processed data as a single observable. The component would then just subscribe once, ideally using the async pipe in the template, which handles the subscription and automatic cleanup for us.
That sounds like a solid architectural approach. Let's talk about the components themselves for a bit. I want to touch on the Lifecycle hooks. Could you describe the purpose of the ngOnInit hook? Why not just put everything in the constructor?
That is a common question. The constructor is really for basic class setup and dependency injection. The ngOnInit hook is used for initialization logic after Angular has finished setting up the component's data-bound input properties. The key reason is that if you try to access an input property in the constructor, it will be undefined because the parent component has not had a chance to pass those values down yet. ngOnInit guarantees that any values passed from a parent via input decorators are available and ready to use, which makes it the best place to fetch data from a server or initialize variables based on those inputs.
Following that line of thought, what about ngOnChanges? When would you use that instead of ngOnInit?
ngOnChanges is used specifically to detect and react whenever a component's input properties change. While ngOnInit only runs once, ngOnChanges runs every time an input property is updated by the parent. It's incredibly useful when you need to perform a specific calculation or trigger a side effect based on a new value. It also provides a SimpleChanges object, which is really helpful because it tells you exactly which property changed, what its previous value was, and what the current value is.
Now, let's get into a tougher lifecycle question. If you are dealing with cleanup or manual DOM adjustments, which hook is guaranteed to run after all change detections are complete for the current cycle? And why is that specific timing important?
That would be the ngAfterViewChecked hook. It runs after every change detection cycle, specifically after the component and all of its children have been checked and their views have been updated. This is critical because it is the only place where you can be absolutely certain that the DOM has actually been rendered and reflects the latest state. If you try to do manual DOM manipulation or certain types of cleanup in ngOnChanges or ngDoCheck, you might be interacting with stale elements. The HTML might not actually reflect the data yet, which can lead to bugs where you are failing to remove listeners from components that have been logically removed, but are still physically present in the DOM.
That is a very detailed answer. Let's shift gears to the templates. You've likely used both template-driven forms and reactive forms. In your experience, what are the major trade-offs between the two?
For me, the main trade-off is simplicity versus control. Template-driven forms are much easier to set up because most of the logic stays in the HTML template using directives. They are great for very small, simple forms where you just need to capture a few fields. However, as the form grows, they become harder to test, and the HTML can get very messy. Reactive forms, on the other hand, move the logic into the TypeScript class. This gives you full control over validation, value changes, and the overall structure. It makes them way more scalable and much easier to unit test because the logic is decoupled from the view. The downside is that they require more boilerplate code to get started, but for any professional project, I usually find that trade-off is worth it.
Speaking of a complex UI, let's look at a scenario. Imagine a component needs to react not only to its own property changes, but also to changes originating from a deeply nested child component. How do you manage that without making the code a nightmare?
Yeah, the biggest mistake there is prop drilling, where you pass event emitters up through 5 different layers of components. It makes the intermediate components bloated and hard to maintain. The most effective approach is to avoid that and instead use a shared service with a subject or behavior subject. By using an observable pattern, the deeply nested child component can simply push a value into the stream in the service. The parent component, no matter how high up it is, can subscribe to that same stream to react to the changes. This completely decouples the components. The child doesn't need to know who is listening, and the parent doesn't have to pass emitters through every single layer of the component tree.
Let's talk about directives for a second. When should you choose a structural directive over an attribute directive?
You use a structural directive when you need to change the layout of the DOM by adding, removing, or replacing elements entirely. Structural directives modify the structure of the page, which is why we always see them prefixed with an asterisk, like ngIf or ngFor. Attribute directives are for when you want to change the appearance or behavior of an element without actually altering the DOM structure. They just modify the properties or styles of an existing element. So if you want to change the color of a button based on a condition, that is an attribute directive. If you want to decide whether the button should exist at all, that is a structural directive.
Good distinction. Now, let's go back to the basics for a moment to make sure we're aligned. What is interpolation in Angular, and how is it denoted?
Interpolation is basically a way to display dynamic data from the TypeScript class directly onto the HTML template. It allows you to embed expressions or variables into your view. In Angular, it is denoted by double curly braces. The framework treats those braces as placeholders and replaces them with the actual value of the variable during the rendering process.
And just to be thorough, which decorator do we use to mark a class as an Angular component?
We use the component decorator. That is what tells Angular that the class isn't just a standard JavaScript class, but a component that controls a piece of the UI. It allows us to define the metadata, like the HTML template, the CSS styles, and the selector that tells Angular where to insert the component in the page.
Let's go back to the async side of things. You've used observables quite a bit. For a developer coming from a standard JavaScript background, why are observables preferred over standard promises in Angular?
The biggest difference is that a promise handles a single event, and then it's finished. It's one value, one time. An observable provided by RxJS can emit multiple values over a period of time. This makes them much more powerful for things like WebSockets, user input streams, or any data that changes frequently. They also give you significantly more control. For one, you can cancel an observable subscription if the data is no longer needed, which you can't really do with a promise. Plus, you have access to a huge library of operators to filter, transform, or combine multiple streams before the data ever even hits the component.
You've mentioned RxJS a lot today. To make sure I have the full picture, if you had to explain an observable to someone who has never used it, how would you describe it?
I would describe an observable as a blueprint for a stream of data that arrives over time. Unlike a regular function that returns one value or a promise that returns one value and ends, an observable can emit 0, 1, or even an infinite sequence of values. Most importantly, it is a lazy producer. That means it doesn't actually start sending data until a consumer subscribes to it. Once that subscription happens, the observable pushes values to the consumer until it either completes successfully or hits an error.
Let's talk about routing. What is a root guard? And can you give me a real-world example of when you would implement one?
A root guard is like a security checkpoint for your application's pages. It's a piece of code that decides if a user is allowed to navigate to a specific route. When a user tries to visit a page, the guard runs a check and returns either true, which lets them through, or false, which blocks the navigation. You can also redirect them elsewhere, like a login screen. A common example would be an authentication guard, specifically can activate. You would use it to check if a user is logged in before letting them see a private dashboard. You could also use it for role-based access, like ensuring only a user with an admin role can access the settings page, or even to warn a user if they have unsaved changes in a form before they navigate away.
I want to challenge you with a high-level design question. Suppose you are tasked with designing a highly reusable component library module. How would you ensure proper encapsulation and versioning so that other teams can use it without breaking their apps?
To do that properly, I would start by using a mono-repo tool like NX or Angular CLI workspaces to keep the library physically separate from the main application code. For encapsulation, I would be very strict with the public API surface area. I would use a public API file to explicitly define which components and services are exported and keep everything else private. This prevents consumers from accidentally relying on internal logic that might change. For the look and feel, I would implement a design system using CSS custom properties for theming. This allows users to override the styles to match their own branding without having to modify the library source code. Finally, for versioning, I would use semantic versioning and integrate a tool like conventional commits. This allows us to automate version bumps based on the type of change, ensuring that any breaking changes are clearly marked in the version number so teams know when to be cautious during an update.
That sounds like a very professional approach. It sounds like you have a strong grasp of both the day-to-day implementation and the broader architectural patterns of Angular. To wrap things up, is there anything else you'd like to share about your experience or any questions you have for us?
I think we covered a lot of the key areas. I just want to add that over the last 2 years, I have really grown to appreciate the importance of maintainability. I've learned that writing code that works is only half the battle. Writing code that the next developer can actually understand is where the real value is. I've been focusing a lot on documentation and consistent naming conventions. As for questions, I'm curious about how your team handles state management for your larger applications. Do you lean more toward services with BehaviorSubjects, or do you use something like ngRx or Akita?
That's a great question. We actually use a mix depending on the project size, but for our current main project, we use a modified version of the service-based state management you described today. We've found it fits our scale better than a full Redux implementation. Anyway, it has been a pleasure talking with you. We have a few more candidates to speak with, but we will be in touch very soon regarding the next steps.
Sounds great. Thank you for your time.
Thank you, take care.